we're going to do that today. And then we're going to do kind of like a mini, kind of a mini workshop on brakes. We've had, last week we did the Transforming Driving Experience workshop, and the thing that people were most interested in or got the most out of was brakes. So I thought we kind of do some brake things here this morning. And then, of course, we've got questions. And like I say, we've had a number of people asking about the Speed Therapy Society. So we'll be giving some more information. I see Joe's here already, and Calvin, Facebook user, who knows that is. I think Carrie says you have to click something so we know who you are. Otherwise, you're just the anonymous Facebook user. Okay, so let's go, moving right along. Let's start with measuring wheel clearance. Now, as you know, Forge Line is our premium wheel. I mean, we use Forge Line wheels a lot. I mean, they're not cheap. They're a really expensive wheel, but they are the absolute best that's available, period. And you're not going to find a better wheel than Forge Line. And they have a little chart. I'll kind of hold this up so you can see it. And you just kind of fill it out, and it asks for a whole bunch of measurements, and they give you kind of a chart over here to show where you're going to make those measurements, and you fill out those measurements and you send it in, and they'll come up with the right wheel and right wheel spacing for you. So I think what we're going to do is we're going to have this. I only have a copy of this. I don't have the scan, so we'll get that scanned and we'll get it out to the Speed Therapy Society, Kenny Brown Speed Therapy Society private Facebook group. Got every single word in this morning. But yeah, I kind of asked it. Look at this one backwards. It talks about the window that the wheel will fit in, the offset between the face of the wheel, where the calipers are, and we're going to talk about. Yeah, I do have my caliper template. That'll be under the brake section. Anyway, that's where we are on wheels. Again, let's see. I think what we're going to do, I'm going to do some questions. Then we'll talk a little about the Speed Therapy Society, and then we'll do my little brake thing. And I got stuff scattered all over this place to show you this morning. I got rotors, I got brake ducts, I got fluid lines, templates. So it'll be kind of good. Oh, you might notice I am wearing my wrong side Speed Therapy Academy polo shirt today. That's something when people join the Speed Therapy Academy, that's one of the first things they get. They get a little care package that has a notebook back there and a polo shirt. So let's go down some of the questions. BC wants to know, how do I install an IRS in my New Edge Mustang? Well, that's pretty darn simple. All you got to do is get one and bolt it in. It bolts right up. I mean, the New Edge came out in '99. That's when IRS came out. So all you got to do is get yourself an IRS and bolt it in. It's pretty darn simple. And don't forget, we're the only company in the aftermarket that not only understands the IRS, but completely supports the IRS package with a range of parts that you won't find anywhere else, up to and including taking the carrier and cutting all the pickup points off and then putting them back on to really change the geometry in the IRS. So that's, if you're looking to do an IRS, give us a call. We're the only people that really know what they're doing with the IRS. Let's see. This is actually a question that Maggie had in the workshop last week. We thought it was a really good question, so we thought we'd pass it along. So S197, that's 07 Shelby GT500 with 750 rear wheel horsepower, which is a ton. I can imagine just how unwielding it can be when you put your foot down. It says K-link or panner bar. Will the K-link lower the roll center enough to compensate with the stock K-member up front with the low roll center? Okay, that's a really good question because with that much horsepower, the tail of the car is kind of like wagging a dog all the time. The thing about the K-link is that it's a pretty sophisticated piece of suspension, and it does amazing things. It creates more rear grip than any other live axle suspension, period. Absolute period. There's nothing that creates more rear grip. The problem is it creates so much rear grip that we actually have to rebalance the car with springs, the way up and rear spring rate. If you were to put the K-Link on with a stock K-member, what would happen is you would, as you go into a corner, you turn the wheel and it would have really good turn in, and then it would just wash out. The rear grip would completely overpower the front grip, which is why it needs to be part of the full system. We really should have the front grip kit. As you people know, I've only got 3 parts of my S197 suspension: rear grip kit, front grip kit, and springs and shocks. And you really have to have that front grip kit to make the K-Link work really well. Aside from that, we have a ton of GT500 people that put just the rear grip kit on, which is, it's a complete package. It's a system. I mean, we sell parts, but we really don't sell parts. I sell systems, an completely engineered system. Everything in the rear grip kit is engineered to work with everything else in the rear grip kit. That's why it has just an amazing transformation of the back of the car. In fact, what I do with geometry works so well, we throw the rear sway bar away. But that would be, if you're keeping the stock K-member, that'd be a better starting point. Because I tell people, if they're going to upgrade their car in stages, rear grip kit, springs and shocks, front grip kit. So anyway, but the K-Link, actually, we're going to do another webinar, a third introduction webinar of the K-Link. Is going to be, I believe, September 22nd. It'll be on Zoom. So it's something you're going to have to register for so you can get the link. So there'll be more information coming up on that in the near future. But yeah, I mean, the rear grip kit, that's the place to start if you don't do the front grip kit. So, okay, moving right along. This is another question that came up last week. In cooler climates, how do I find a tire and brake pad that will perform fast for autocross? Well, here's the thing. As far as the tire, I mean, that's a great question. The thing is, a lot of different groups have different tire requirements, whether it's a open tire, 100, 200, and that's a really hard question for me to answer because I don't know what tires they allow. But certainly you want to get the stickiest tires that you can get that's allowed within the class you're running. And as far as brake pads, I have a fabulous answer on brake pads, which will be coming up a little bit later. We're going to talk, why there's different brake pads for different applications, and why I say you always use a street pad for the street and a track pad for the track, and never the twain shall meet, because they both do different things. They both operate in different temperature ranges. Okay, let's see. Here's another good one. I bought a 03 Mach 1 with slotted rotors. How do I know the rotors are on correctly or backwards? Again, that'll be coming up too in the brake section, and that is a really good question because it's absolutely super critical important that if you've got slotted rotors, you put them on correctly. We had one customer bring his car in that had somebody out near where he lives looking after it, and he just kept burning up the brakes and burning up the brakes. He was having a lot of problems with the brakes. So he brought it to us, and it was pretty easy to figure it out. Whoever was working on the car put the rotors on backwards. So instead of pumping cool air from the middle out to cool the rotors, it was actually sucking air in and heating up the rotors. That's why it's burning up the brakes. So it's a good question, and I've got a great answer, which we'll be showing you a little bit later on. Here's another one. Do you like higher roll center to increase mechanical grip, or is the stock roll center already too high? Well, it's kind of like yes, no, and not really. Okay, is the stock roll center already too high? Yeah, absolutely. The roll center in a Mustang is where the panel bar crosses the center line of the car. That's the roll center, and that's the part of the car that the back wants to roll around, and that's pretty high. That's why if you're in a stock Mustang, you go around the corner, you can actually feel the inside tire get kind of light. That's because the car is rolling so high. I move the roll center down as low as it can go on a live axle car, theoretically. Okay. What we do is we take the panel bar, we move the panel bar all the way down to the bottom of the differential. Now, I don't use Watts links, and a very good reason why. Where a Watts link, where the center pin is for the bell crank, that's the roll center. And you really can't move that roll center down very much. I mean, maybe an inch or two, but not a whole lot, just because of the mechanism. Plus, you've got to have more attachments on the thing, to pick up the rods on it. So back in the Trans Am days of old, we used to take a Watts link and mount it horizontal to the bottom of the differential. So we got the benefits of a Watts and the lower roll center in the bottom of the diff. But that was easy because they had like an underslung chassis, so really easy to run rods right across the chassis. That's a little impractical. So the easier solution, just take the penter bar, lower it down to the bottom of the differential, which works really well with the rest of the rear grip kit, which changes the side view geometry, the anti-squat. It just works really well. So the roll center is increased the mechanic. Do you like a higher roll center? No, I don't like a high roll center. I like a low roll center. In the whole AGS 4.0 system, the rear grip kit, front grip kit, we bring the rear roll center down, the front roll center up. So as you go around the corner, the car doesn't want to roll out on the front tire. With the stock Mustang lowered, you've got the rear roll center is really high in the back, and the front roll center is underground, which means it goes around the corner, just rolls all the way onto that outside front tire, which is why you turn into a corner with a Mustang going fast and it starts to understeer because that tire is getting completely overloaded, all the weight's on it. So anyway, low roll center, and the rear grip kit lowers it to the bottom of the differential, which historically has been as low as you can take a live axle rear roll center until now. And if you sign up for the K-Link webinar, you're going to see how ingeniously I have taken and lowered the rear roll center even more. That's why they have so much darn grip. So, okay, let's see, we've got through our questions. This brakes are important, and I like really, really good brakes for a couple of reasons. Number one, they help you stop when you're going really, really fast. And secondly, you can use your brakes to really significantly improve your lap times. And we'll talk about that in a little bit. But the first thing you need to know about brakes is actually energy. Now, the Mustang is what, 37,800 pound lump of mass rocketing down the straightaway at 120 miles an hour. And there's only a few ways to slow it down or stop it. Trees, guardrails, and concrete barriers are the least desirable, although they are very effective. It's more desirable to use your brakes. So what happens when you put your foot on the brake pads and rotors take that kinetic energy of that mass moving at high speed and turn it into heat energy. That's why brakes get so hot. They're taking kinetic energy and converting it into heat energy. And by converting it into heat energy, they're slowing that mass down. So that's why, a lot of people don't understand the importance of knowing the heat in your braking and your brake pads and your rotors. So we're going to start with, let's see, so I got a lot of stuff hanging around here. I think I'll start with my big old rotor back here. Okay, this is a two-piece slotted rotor. I'll tip this down a little bit. If you can't afford a big brake package and you want to improve your brakes, get a hold of us. We'll get you set up with two-piece slotted rotors. Now, two-piece slotted rotors do a lot of things. First, they're lighter than the factory. Secondly, they have these slots. Now, what these slots do has two functions. One is to help clear brake dust. The second is when you've got a brake pad on a rotor at high temperature, they actually will build up gas on the trailing edge of the pad. Back in the early days in the 86 Celine cars, in the racing the Escort, the SCCA Pro Endurance Series, we had obviously had to change brakes multiple times in 12 and 24-hour races. What happened is the brake pads would come off and the fronts would be worn out and the back of the pad would have about half the brake pad there. Well, the reason for that is the gases were building up at the trailing edge of the pad, and we weren't getting a good contact, so it was wearing the fronts out. By having these slots, it'll evacuate that gases that get trapped at the back of the pad. Okay, another thing is that because the outer ring is steel and the inner ring is aluminum, they don't really transfer as much heat from the rotor into the wheel bearing or into the wheel. So that's why they run so much cooler. And they're vented inside, so they actually pull the air out. Now, a brake rotor cools itself from the inside out, which is why we put brake ducts in the middle. We'll get to that in a minute. Another thing, while I've got this up here to talk about, is temperature. So the question is, how do you know what temperature your brakes are really running at? I know people ask if they can use a laser temperature thing to check their brake temperature. And no. All that's going to tell you is what the cool down temperature is of the rotors. What you want to know is what is the peak temperature of the rotors. I don't know if you've seen like endurance racing or at night, going into a corner, all of a sudden the brakes just glow bright red. That's because they're getting really, really hot. That's the temperature you want to know. What is the maximum temperature those pads are getting up to? Now, this little thing right here, that's called brake rotor paint. It's really handy stuff. I think we sell more of this than anybody else in the aftermarket. And it's one color. You know, back when I started, you had to have 5 different colors and you paint them all on, and each color would kick off at a different temperature. So you had to check all the temperatures to see what temperature your brakes were running at. But with this, it's just one color. It's really cool. And they give you a little chart that kind of tells you, let's see if you read that or not. But you match the color up to the temperature range, and I'll tell you what temperature your rotors are running. Now, mine typically run on my cars about 1,200 degrees, so I pick brake pads out accordingly. Now, see, because I got it up here, I want to touch on brake ducts. If you're doing track, you really have to cool your brakes. Like I say, my brakes on my Mustang run about 1,200 degrees with brake ducts. Without brake ducts, they'd be off the chart. And my brake ducts are completely unique, although somebody else is sort of copying it. But I've been doing this since SN95 days. But if you notice, it's not round. I use a 3-inch brake duct, but it's oval. Well, the reason for that is by making it oval, we can actually, if you can see, all of the air coming in goes directly into the eye of the rotor. So 100% of the air hits the eye of the rotor, and once it's in there, the vanes will pull it out. So that's why they're squished, because we can get all the air into the rotor. Now, there's some people have like 4-inch brake ducts, which you'd think would be better, except if you saw how that 3-inch just barely fit in there, a 4-inch actually like goes into part of the rotor. So that does a couple of things that aren't really good. Number one, it's putting air on the interface of the rotor. So it's actually getting a different flow of air than the outer side of the rotor. And also, as the air comes in and hits it, it kind of disrupts the flow because it has to tumble and go around it into the center. We did a back-to-back test, 2010, with my 3-inch brake ducts on my car and the 4-inch brake ducts on the Ford Racing FR500S cars. And the overall rotor temperature was similar. Mine were just a few degrees cooler, but the big difference is rotor temperature on mine was the same inside and out. Where with the 4-inch, it was cooler on the inside and hotter on the outside, which explained why the outside pads wore more than the inside pads. So that's why brake ducts are so important. Now that's the S197 brake duct. We've got it for SN95, again with the oval. And something interesting for the 550 cars, it got such a big rotor, we didn't have to squish it. So just a 3-inch hose goes straight into the rotor and cools it down. Okay, another important part of brakes is, there we go, braking is brake fluid. You really, if you go on track, you absolutely have to have high temperature brake fluid because the high heat will boil regular brake fluid. And what happens is it boils, you hit the brake pedal, and you got nothing. You got absolutely nothing. So we actually switched over a year or so ago to the Bear is having this formulated in the UK. And it's about the highest dry boiling point of 608. And it's a lot more cost effective than some of the fancy brand name brake fluids. So that's what we've switched to. And, at the track, I tell people, bleed your brakes a lot. Bleed them before the event, bleed them Saturday, and bleed them Sunday. And I always like fresh brake fluid in my calipers. Okay, something else that if you don't get a big brake kit and you do tracks, stainless steel brake lines. But the reason for that is, stock brake lines are rubber, and certainly it's heavy duty, stress tested and all that. But when you start seeing really high temperatures in your brakes, the fluid's going to get hot, which means the brake line is going to get hot. And if rubber starts getting hot, it starts to get a little soft. So you do have the opportunity for, if you're getting really hot brakes, you hit the brake pedal, and that brake line is going to just a little bit, which is going to take some of your pedal feel away. Or if you've got stainless steel lines, they've got it's a solid Teflon inner lining, which means there's absolutely no give at all. I mean, you got a rock hard brake pedal no matter what. So that covers rotors, paint, ducts, fluid, lines. Well, let's talk about brake pads themselves. Let's see. Okay, here's a little chart I put together of the brake pad system that we've kind of developed. This is what we switched over to about a year or so ago. It's working out really, really well. And you can see each one of these brake pad compounds has a different operating range. And if the street performance goes from 0 to 800, now a regular OE type pad, I don't know for sure, but I'm guessing that they work from like -20 to maybe 300-400 degrees. But above that, they'll wear out really fast. There's three elements to brake pads: wear, heat, and friction. If you're living in the optimum range for the brake compound, you get good wear, good friction, and good heat. If you have a compound in like a street pad that on track, and you start getting above the operating range of the compound, then the wear increases dramatically and the friction decreases dramatically. So that's why I always have to pick the right brake pad for the right application. So these are the pads that we now offer, and I'll kind of go through them. The street pad, street performance is good from 0 to 800, which is a little more than other performance street pads. And then we've got an autocross pad, which goes from 0 to 1,000, which should be more than enough temperature to handle brake temperatures on autocross. In fact, a lot of autocross could probably get by with the street performance, but the autocross pad up to 1,000 degrees would be even better. And then there's the novice track. If it's first time or so on track, then you're not going to see really high brake temperatures because you're not going to really get into really hard braking. But after a couple of events, you're going to start braking harder and harder, and the temperature is going to continue to rise. So the going from 74 to 1250. Now this is also a pad you could drive to the track, although because it's more of an aggressive compound, I really wouldn't be recommended for daily driving because you'd probably pick up some dust and noise because it'd be operating below its desired operating temperature. But that's, from 74 to 1250, kind of gets you through the first couple of track days, and you can drive it to the track. Now, the next pad up is from 118 to 1400. My brakes on my car run about 1200 degrees, and this would be an okay pad for that. But that 1200 degrees is really close to 1400 degrees. I want to be closer to the middle of the operating range. So the next pad up goes from 173 degrees to 1800. That is kind of like a really good pad for track days because if you're running 1200 degrees, that's sort of in the middle, and that's where you want to be. But there's little combinations like for a lot of track people. I'll have them use the 1800 and 1400, 18 on the front, 14 on the back. Maybe for some people that really aren't advanced, might even go to 1400 front and 1200 rear. And then we keep going up from there. I mean, the harder you drive, the faster you go. The more aggressive brake pads you need, the more temperature you make. And then we've got a race pad that's from 225 up to 2100. And then we've got a pro race pad that goes from 610 to 2100. Now I had, you really need to match your pad to your temperature. I talked to a gentleman maybe 2 weeks ago in one of my 15-minute consults. We were talking about brake pads, and he said, you know, the brand that we were using now, he didn't like them at all. He said they were terrible pads. And I said, well, what compound were you using? He said, I was using the 18. He said, the guy that sold it to me said, I have a heavy car, it was GT500. I have a heavy car, I needed the best brake pad. Well, you take a look at that, and the operating range is from 610 to 2100, which means that, you know, if your brake pads aren't operating in that 14, 15, 1600 range, they're out of range. So what's happening, he had too aggressive a pad. He wasn't getting them nearly hot enough. So they didn't work very well. They made a lot of dust, and they squeaked. That's something, if you ever hear like a car on track, on a racetrack, and the brakes squeak, their compound is too hard. They need to drop down a temperature range. So that's why it's important getting the right range for what you're doing. And you know, you can, if you're interested and need to have some direction, you know, sign up for one of my 15-minute consults. We'll talk about your car, what you're doing, and I'll come up with some compounds for you. The other thing is these can be pre-bedded. Now, what is brake bedding? Well, anytime you've got like a competition pad, they have to be bedded. What that means is they have to reach critical temperature so that all the volatiles from manufacturing boil out of the pads. And that's done by repeated high-speed stops. Stop, let it cool a little bit, stop, let it cool a little bit. And you keep doing that until one time you hit the brakes really hard and the pedal is hard as a rock and you smell brakes. That tells you that that's the time to stop. And you take your foot off the brakes and you gently drive back to the pits, let them cool completely, and the next time you go on track, you have demon brakes. So with these, we can get them pre-bedded because typically that'll eat up at least one session bedding brake pads. And so this kind of eliminates that. You can just put them on and go. So, and then also with rotors, you need to kind of season them. You got new rotors, you can't go out and hammer the brakes. You got to, you know, bring the temperature up gently to get to the point of operating. So that's why it's so important to get the right brake pad for the right application. You know, if you've got too soft a brake pad, like the 1200, and you're running a Mustang pretty fast, and you're going to be right up on the edge of that 1200 degrees, and they're going to, will it take it? Yeah, it'll take it, but you're going to see a rapid increase in wear and a decrease in friction. So, and then the same thing, if you get too aggressive a pad, it's just the opposite. It's not going to work. So, okay, that's my little chart on brake pads. I think that's everything on brakes today. That was quick.